Today we will do Mercator charts. Now on a globe, if this is the equator, let's say India is close to the equator. Now on a globe, whether India is near the equator, which is 0 degrees latitude, or at a high latitude, let's say 60 degrees, it will appear as the same size. But when this is represented on a plain paper, there will be a slightly distortion. So there are various of projections or charts, mnemonic charts, Mercator charts. Mercator charts are the most popular. So when the world is laid on a plain paper, so if this is the equator, and let's say India is near the equator here, let's say 0 degrees latitude. So the property of Mercator charts is when a round shape of a globe is laid on a plain sheet of paper, there is a distortion, and as the latitude rises, it gets stretched. So if India is here, let's say this latitude at the south point is around, let's say 10 degrees north, and in the northern point, it is about, let's say 11 degrees. Now, if India was to be projected in the high latitude of, let's say 60 degrees, 60 degrees, it would appear almost like a double size. Now, here if you see from 10 degrees to 11 degrees latitude, and if you measure this part in centimeters, let's say it will be 1 centimeters. But if you check the size of India at 60 degrees latitude, south part of India, and north part, let's say 61 degrees. Now, if you measure this part in centimeters, it might be double of this, 2 centimeters. That means 1 degree of latitude in low latitude, let's say it's 1 centimeter here, but in high latitudes, 1 degree of latitude in high latitudes will be much more, let's say 2 centimeters. But your nautical miles distance will be the same. Let's say from south of India to north of India in low latitudes, it is 1 degree, which is 60 miles, nautical miles. And if you measure the same India, which looks bigger in high latitudes, again the centimeters might become double, but if you see the nautical miles, it will be 61 minus 60, which will again be 1 degree. So this is the property of Mercator charts. Now let's do another topic about the bulbous bow. Earlier ships were designed like this, there was no bulbous bow, but later on some research was done and they started constructing the ship with a bulb over here, and this was known as the bulbous bow. So this became part of the four-peak tank which was here. The water goes to the bulbous bow also. This is part of the four-peak tank. So what is the purpose of bulbous bow? There are two purposes. One is it increases the speed of the vessel with the same fuel consumption, and second it reduces pitching of the vessel. And there's another part of the construction which is known as Bilge Keel. Now what is this? If you see a ship like this is the starboard side of the ship, this is the port side, this is the main deck, this is the water line. This is the turn of the bilge. That the vertical part of the ship becomes horizontal. So turn of the bilge. So here, like a flat bar, a small plate is welded on both the sides, and this is known as the bilge keel. And if you see the ship like this bilge keel is not in the from forward of the ship to aft, it's somewhere just forward of midship to aft of the midship. Let's say 50% of the length of the ship from here to here. And what is the purpose of the bilge keel? It reduces rolling of the vessel.